Yes, this is a question under the Makokha theorem, under complex number still. You have, if given the question, if z raised to 5 is equals to 4 minus 3j, find z in the form of a plus jb. And you can see it is 12 marks. Under solution, a plus jb, this is in Cartesian form. Now first of all, we write z raised to 5 is equals to 4 minus 3j, and this can be rewritten as, when you want to make z the subject of the formula, it means it will be z is equals to 4 minus 3j, the fifth root. It's like you find the fifth root on both sides. So it will be z is equal to the fifth root of 4 minus 3j. And z, this one can be rewritten as, again, as 4 minus 3j raised to a fifth. We determine the next modulus abbreviated as r, which is a squared plus b squared square root of it. After, now the a is the real part, while b is the imaginary part. We have the two parts, imaginary, the real part and imaginary. So we have a 4 squared plus negative 3 squared, the square root. If you square root, you will get as the modulus as 5. After getting the modulus of 5 as 5, let us go for, or calculate the argument theta. The argument theta is equals to tan inverse of imaginary all over the real part. So we have tan inverse of negative 3 imaginary part all over the real part. And before we find that angle, let us try to represent that a complex number on a Gantt diagram, to confirm if it is E or the theta we want. So if we represent, this is 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3. So let us represent, this is negative, this is the real axis, and this is the imaginary axis, y. So this is real. So it means now when you want to represent, it was 4, so you go for 4 positive and negative 3 on imaginary. So it is here. So it will be this one. So this is your z as 4 minus 3j. You have already represented that complex number on a Gantt diagram. So we can see it is theta. It is not theta we want, it is E. The angle we'll get here, it will be E. Now, tan inverse of negative 3 all over 4. When you press tan into your calculator, tan inverse of negative 3 over 4, we get that it is 36.87. So if it is 36.87, let us try to press tan inverse of negative 3 over 4, tan inverse of negative 3 over 4. You have negative, it is negative, so it will be negative. Negative shows that the direction was clockwise, not anti-clockwise, so that's why it is negative. So it will be E is 36.87. The negative show that the arrow, the direction, the opposite direction. It should be anti-clockwise, but this is clockwise. So the theta now itself, it will be 360. We want to get the whole part of this, and angles at a point add up to 360. So subtract this 36 here, 36.87 from 360 to get the theta we want. So minus 36.87. This is theta, this is theta. The theta we want is, we have 323.13 degrees. Good, that is the theta we want. And here we proceed. Here we say, we state the Moivre theorem equals to r cos theta plus j sin theta, z raised to n, r raised to n cos n theta plus j sin n theta. So we have z1 is equals to, we have r as 5, n is a fifth, this is a fifth, into cos n theta. So n, we have a fifth multiplied by theta, which is 323.13, plus j sin 1/5 multiplied by 323.13 degrees. So z1, we have z1 as, when you 5 raised to a fifth is the same as the finding the fifth root of 5, which is 1.4 into bracket cos. When you multiply out, you simplify a fifth multiplied by 323.13 degrees, it will be cos now 64.63 plus j sin, it is the same, 64.63. So z1 is equals to 0.5998 plus j1295, and that is z1. So we continue, but for z2, we must find the regular, what you call regular interval. We must find the regular interval, that is angle, and we have the formula 360 all over n, and n here is 5. So it's 360 divided by 5, this is 72. This is the regular interval between the roots. So for z2, let us substitute 1.4 r into cos. You add 72 to this angle to get the another root. So it will be cos 64.63 plus 72.0, that is 136.63 plus j sin 136 again 0.63. Having your z2 as, when you simplify out, you multiply this 1.4 by this one, again 1.4 by sin this one, you will get that it is negative 1.018 plus 0.9614j. This is your answer as z2. Then we continue next. For z3, you just take the interval, regular interval, that is the 72, you add to this one as you move. So you have 1.4. When you add 72 to this, it will be cos 208.63 plus j sin 208 still 0.63. So you have, when you simplify out, take this one, multiply by this, you open the bracket again, this one by this, you get your z3 as what? Negative 1.2288 minus 0.6708j. This will be your z3. What about z4? Again, you take the regular interval 72 you add to this angle to get the next root, which is Z4. It will be 1.4. 1.4 will retain or remain as 1.4. Will be the same 1.4 into cos. If you add 72 to this one, it will be 280. 280.63 plus j sin 280.63. Your Z4 will be, if you multiply this one out, it will be Z4 will be 0.2583 minus 1.374j. We continue now. For Z5, it will be, you add again this one, add 72 to this one, because 72 is our regular interval between the roots. You add to that one, so it will be 280.63 plus 72, that is 1.4 into cos. When you add them out, it will be 352.63 plus j sin 352.63. If you simplify out, you take 1.4 by cos this one again, 1.4 by this sin, it will be Z5 as 1.388 minus 0.176796j. So answer Z1 is equals to 0.5998 plus j 1.295. Z2 is equals to, then 2 was negative 1.018 plus 0.9614j. Z3 was 1.2288 minus 0.6708j, and Z4 was 0.2583 minus 1.374, and lastly Z5 is 1.388 minus 0.1796j, and that is your answer.